Today, we will show you how to securely serve private CDN content using CloudFront signed URLs. So first of all, what is the CloudFront CDN? So CloudFront is an Amazon product, and it is a content delivery network, CDN, that can be used to deliver data, videos, applications, etc. to anyone globally with low latency and high transfer speeds. So CloudFront uses S3 buckets, which is what we will use in this example, but it can also use EC2 instances and other AWS resources to cache and serve content. So let's go ahead and look at a picture example. So we have users all over the world. And users will go to a local cache over here, which has a copy of what's in this S3 bucket, right? So the local cache will check whether the file is there. If it's not, it's going to go out and fetch it from the S3 bucket. So a benefit of CDN is that the users are close to the data, so that's why you get the low latency. Okay, so let's go ahead and describe what are the signed URLs. So signed URLs basically allow the admin to restrict access using some rules, such as an IP address or expiration time, or even begin access time, when the user can access this data. So some examples of where you might use signed URLs include serving paid content to customers, right? If someone purchased a subscription, they have access to these files, this bucket, for an amount of time. You can use it to share private documents, right? You can put a document in a bucket and then send a signed URL link to users to access it. Maybe you can provide a temporary access to a file for a limited time. In our case, we're going to be providing a software installer that's only going to be valid for a period of time. Or you simply want to simplify the user experience without having them to log in and still have access to some resources. So we'll take a look at what a signed URL looks like once we generate it, but it can be quite lengthy depending on the limits you apply to it. Well, so let's go ahead and jump into creating the signed URLs. We got basically 4 basic steps. To summarize, we're going to create a CloudFront distribution, create a key pair and add it to a key group, then associate that key group with the CloudFront distribution, and then we're going to use the AWS SDK to generate the signed URL. So as a prerequisite, you need to have an S3 bucket with some content in it, right? And basically set that bucket to private access, which should be the default for AWS. All right, let's start with the first step, creating a CloudFront distribution. So go ahead and go into your CloudFront console and create distribution. As the origin, choose the S3 bucket. So I have a bucket here for testing. And under origin access, click origin access control settings, right? So this is needed so that the CloudFront distribution has access to the S3 bucket, because your S3 bucket should be private by default. And we're going to click create a new OIC, leave all this as default, click create. Let's just call it something else. Looks like this name has been reused because I've been playing around. And then we need to set our firewall, so we're going to set it to none. You can set any other settings you want, but we'll leave everything as default for now. We'll click create distribution. And now you should have this yellow banner that pops up. We're going to copy this policy, and then we're going to click this go to S3 bucket and it should take us to our S3 bucket console. It may take a little while to freshen this up. Okay. And then let me make this bigger. Then over here, we have our bucket. We have our hello world file here for testing. We're going to go to permissions, and we're going to have a bucket policy. As you can see, I've been playing around with this bucket policy, but what you're going to do in this bucket policy is click edit and basically just paste whatever you copied earlier up here in the CloudFront. And then we're going to click Save Changes. So now we have a policy where the CloudFront can access this S3 bucket. So at this point, if we go back here, we see that this is still deploying. Let me refresh this. Still deploying. This means if I try to access it via a URL, and then it is hello world.txt. Basically, it's not deployed, so it's not available yet. But another thing to point out is we have not set up signed URLs yet, right? So the CloudFront is public access. So at this point, we can wait for it to be deployed and tested, but we can also do the next step in parallel. So the next step is going to be creating a key pair and adding it to a key group. And that is the recommended way to sign URLs, is using trusted key groups. So let's go ahead and jump into our terminal and create a private key and a public key. I've got a terminal up here, and I'm going to use OpenSSL, OpenSSL, gen RSA out private key.p PEM format, and we're going to use 2048, pretty standard. And then we're going to create, so that creates a private key, so we can create an associated public key, OpenSSL RSA pub out in private key out public key. So we have our private key and public key. So let's go ahead and jump back into our CloudFront console, CloudFront, and we're going to go to public keys, and we're going to create a public key name. Let's call it sign demo, and we're going to paste our public key over here. Let's go ahead and grab our public key. In this case, we can just open up and grab it right here. Copy, paste. Jump back in here, paste it, and create public key. So we created a public key. Now we want to add it to a key group. So we go to a key group and we create a key group. We're just going to call it the same, call it sign demo, and we're going to choose the one we created here, create key group. So we have the key group created. So the next thing is to associate this key group with our distribution. But before we do that, let's go jump into our distribution, see if it's been deployed. Okay, so last modified is up here. So now we can actually go ahead and test this link to make sure it is working. Okay, it is working. Hello signed URL, but it's not signed yet because we haven't enabled signing. So let's go ahead and enable signing. Jump back in here. We want to go to behaviors. So let's go to our distribution. And let's go to behaviors. And I mean, you can specify the path pattern, right? You can create a new behavior, but we're just gonna apply the signed URL to everything in this distribution. Click the default one, edit, and then we go here, restrict viewer access, yes. And we're gonna use the recommended trusted key groups, and we're gonna select our sign demo key group here. And I think that's all we need to do here. We save changes. And let's see if it's immediate. So let's go back here and try to reload this. Looks like it's not immediate. It's not immediate, so it's going to take some time. We're going to go back and test this later to make sure it's been restricted. Let's see. Let's double check just to make sure we have it there. We are restricting access. Yes, 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 yes. We're restricting access. Okay, it just hasn't propagated to the CloudFront cache yet. Okay, so the last step is actually creating the signed URL using, you can use an API. There's documentation for using API, but we're going to use the AWS SDK. And Amazon does provide a few examples: Perl, PHP, C#, Java. But in our case, we're going to use the Go programming language. Let's go ahead and jump into our IDE. So we have an empty directory here, and we're going to just create a new Go project. Go mod init CloudFront signed URLs, and go get, and we're going to get the dependency, SDK dependency, which is the only one you should need. So it is the AWS SDK Go version 2 feature CloudFront sign. And I'm going to specify a version here, 1.8.3. The reason I'm specifying a version is so, in case you watch this video in the future, you know which version I used here that worked for me. Okay, go get that version. And then we have our private key.pem file, which we will need. So let's go ahead and write some code. New file, main.go. Package main, and let's define some constants. So what we need as constants is we need the key ID, which we will grab shortly, and then we need the URL to access. And this is the URL I've been trying for the public access. Up here. Copy, let's reload, see, oh, there we go. So the cache is propagated. So now, the access is restricted, and this is, you get a 403 error with this error message. So this is URL I've been testing, and my key ID can be found by going to CloudFront distribution. In the menu, we go to public keys, and this is the key ID. Signed demo here. All right, we got our constants. So let's write a function. And first of all, we want to read in our private key here. So data error OS read file, standard logic here, and we're going to read in the private key.pem. And error handling, you can use panic, you can return an error. Let's use lock fatal F. There we go. Copilot has helped us. It's pretty good for error messages, right? Pretty quick. Okay, so one issue I found with this SDK is it provides its own way to load the private key. It's called sign.load pem priv key. And I see it actually provides another function, load priv key PKCS8. So that is the problem, right? You need to know whether you're passing it a private key in PKCS1 format or PKCS8 format. And, I feel like it's just a bad user experience, right? This load pem private key should just work with whatever format of private key you provided. In our case, if you look at private key, it is PKCS8 format, which we can tell by begin private key, because this message does not tell you that it's an RSA private key. It just says begin private key. And the fact that it's an RSA is embedded in this content. So what we've been using in our project is just a utility function that's based on the Go standard library to parse private keys. So I'm going to go ahead, instead of typing it out, we're using it in our main project. I'm just going to use it here. So this is the function. It's going to take the byte slice, decode it to a PAM block, which it expects there to be a PAM block. In this case, this is the block, begin private key and private key. Then it's going to try to parse it with PKCS1. If it doesn't parse it, it's going to try to parse it with PKCS8. And it only accepts these parameters. If that doesn't work, it tries to parse it using the EC private key function. And all this code is standard in the Go standard library, which you can see up here. So we're going to go ahead and use this code instead of this confusing developer experience that they provided. So let's go ahead and do that. So private key error, and we're going to call our function parse private key. We specify a name which used in the error, so we're going to do URL signer private key here. Once again, check for errors. Now what we need to do with the private key, it comes back as a crypto private key. We need to convert it to a signer because we're going to use this key to for signing the URL. So we're going to call it signer key. And we're going to convert it to a crypto signer. And if we can't convert it, we're going to fail. And then finally, we actually do the signing. Well, not yet. We create a new signer using the key ID and the signer key. Nice try, Copilot, but you guessed wrong. And then it already knows what the next step is, but signed URL error, and then we have signer sign, and then we're going to sign URL to access, and we provide the expiration time, right? So it gives us this help text. Let's see if that works. Nope, wrong again, Copilot. You need to provide a time here. So we're going to do time.now, add 1 hour. So this URL will expire in 1 hour. Now, if you hop into the sign method, you can see that there's other methods you can use, sign with policy, and it gives you some examples, IP address, start time, end time. So you can also use this method up here. Let's go back to our code. We have the signed URL, do error checking, and then we're just going to print it. Signed URL, there we go. And let's see if this runs. I can just click run up here in my IDE, or I can just do it on the command line. So go run main.go. And there we go. We have our signed URL. As you can see, it contains expires, it contains the signature, and it actually contains the key pair ID, right? This thing over here, which even though I had an end line here, it still seems to have worked. And let's see, let's go ahead and click on this signed URL. Just going to copy and paste. Signed URL, here we go. Bam, it worked. Signed URL works. Original URL is restricted. So there we go. That's how you do signed URLs with CloudFront. Hope you enjoyed this video.